Okay, so today we're going to be talking about rotations. So we've talked about, sorry, if we have isometric transformations, that means our pre-image and our image are going to be congruent. Day one, we talked about reflections across a line of reflection. We talked about translations where you scooch the graph on day two. And then today we're going to be saying, okay, pick a point, okay? And then basically put your object on a stick, okay, and rotate it through space a certain number of degrees. And we normally talk about counterclockwise, okay, against which way the clock goes. And so those three, transformations are shown up here, okay? So you see reflections, we see translations, and then we see that there's a rotation. And so, a more specific definition of a rotation is that every point, okay, of a preimage is moved through a specific angle, okay, and then in a certain direction, normally counterclockwise, okay. And so the image of the rotated figure is going to be congruent to the original function or to the original shape. And so, we're going to be, it's hard to do without a grid. We'll do it a little bit. We'll do it once with patty paper, and then we'll also do it with like measuring. You'll kind of watch me do that. I'm going to try to do this on this whiteboard, but it's a little tricky. So, but I won't ask you guys to do that like I do on the whiteboard. We will use a little bit with patty paper because, but again, mostly we'll focus on using a grid. Okay. If a point of the pre-image is the center of rotation, okay, so right here, if this is the center of rotation and you rotate it through space, well, that point doesn't move, okay? See point A and A prime, okay? Just like if you did a reflection back in the first section and you're like, okay, I'm going to reflect this shape across this line here, well, this point right here wouldn't really move, okay? Again, I'm doing this freehand. So if your point is actually on the line of reflection, that point won't change. If your point is the point of rotation, then that point will remain the same. The other guys will move as well. Okay, the point of the, here we go. The center of rotation is that fixed point about which the shape will move in a circular motion to your new position. The angle is how many degrees you move it, okay? And you normally do clockwise. You can highlight that if you'd like to, okay? So clockwise, or counterclockwise, sorry. And then we've got kind of just demonstrated, okay, the distance from this point of the center of rotation, pardon me, of your pre-image point and your image point will be equal, okay, will be the same length, okay, those distances will be equal to each other. And so, look at this is your, I'm going to get a piece of pen, okay, so if this is your center of rotation and you're rotating it through space, my marker's not working the best today, per usual. But if this is your point of rotation right here, your center of rotation, and you're moving things through space, your pre-image C will be this length, but as your image length from the center of rotation will also be the same length. And so same would be true with B. It's just a little bit more awkward to get to there. Okay. The next thing we're going to talk about would be what are the common rotation spots? Well, assume that we start here because this is going to be our pre-image, and we know that because, in my opinion, because it's darkened. Okay, and so we start here, and if we rotate it counterclockwise, this would be 90 degrees, wouldn't it? Okay, that's a common thing to do. 180 degrees would be another thing, and that's what it would look like if you rotate it through 180 degrees. Again, you kind of like put the closest point on a stick, and you rotate that stick the number of degrees. Okay, that's probably the easiest way to think about it. And then from this point, you could also have gone 270. It's the three most common direction or degrees to move. If I said, oh, move it 360, you wouldn't have to move it at all. And so we don't normally do that because it's kind of weird. And so what we're going to practice first on would be can we use our tracing paper to help us rotate this through space? And so the directions are written here, and I can show you how you're going to do it. You'll need a protractor, you'll need some tracing paper. And so how you do it is, first of all, you want to copy on your tracing paper exactly what you see, okay? So trace over this center of rotation and then this segment right here, okay? Because again, we put our shape like on a stick, and because it's rigid, then when we rotate that stick through the degrees, we'll place our space, our shape in that new location by depositing it with our tracing paper. So draw the shape on your tracing paper. The thing is, because we're not going to be flipping it over, the smart choice would be to flip it over and redraw it from on the back side of it, so that when we move our patty paper to the new location, we can deposit it where we want it to go. So we want to go 180 degrees, okay? And so the easiest way to do it 180 degrees, 180 degrees is a linear pair. It's a straight angle. And so the easiest way to do this one is to not even use a protractor, just to use a straight edge and continue this line as far as you need to go. Okay. Don't go forever, but just go for a little bit. Okay. And I should erase some of this because it's going to look ugly if we go too far. Okay. And the thing is, rotate your tracing paper through space. Okay. Counterclockwise. So you'll rotate through there until this stick, your original stick right here, on your tracing paper, it lines up with that stick below, okay? And then when it lines up, well, then you will redeposit this shape right here by tracing on it, and it will deposit that shape. When you pick up your tracing paper, you can darkenly draw that little boot, okay? So that's the easiest way to do 180 degrees, okay? And the tracing paper helps us take the entire shape because it's fixed to that one point to go that degrees, okay? To go 90 degrees, again, the same thing is connect your center of rotation with this right here, okay? And I would draw the entire shape, okay? Trace this shape and make this dot really strong here. Flip over your tracing paper, darken the back side of that shape so that when you rotate it through space, you're going to get it. Now here's where you need it to be 90 degrees, okay? And so you can use your protractor. So you're going to turn your protractor so that we can rotate it 90 degrees through space. So we need this to make a right angle. So you're going to use your protractor to measure this to be 90 degrees, make a little mark. It might be out here because your protractor is pretty big. So align the bottom of your protractor here, make a dot here. You're going to draw a segment here so that when we rotate our tracing paper, we can redeposit our shape right here at 90 degrees. Okay, and then you draw it darkenly. So this is how you draw 90 degrees. You basically would put your protractor on this shape. You know how it looks like a moon. You'd go like this, and it would look like this. And so you would line up the dot with the center of rotation, and you'd make a mark at 90 degrees. Draw this like this. When you rotate your shape through space, then you're going to get it. You're going to be able to deposit that shape there. And my shape does not look very good. Let's fix that a little bit, okay? What would that look like? It would look a little bit more like this, okay? Still a little bit too big, but rotating it through 90 degrees counterclockwise. This one says go 270, okay? There is no 270 degree on a protractor, but we know that if you want to go 270 this way, it would be equivalent to going 90 degrees this way. So what you're going to do is you're going to use your tracing paper and you're going to mark the center of rotation, this little stick right here, and the shape. Flip over your tracing paper and darken the back. You're going to get out your protractor and you're going to line it up like a moon like this, and you're going to make a mark at 90 degrees. You're going to draw this out a little bit so that when you rotate it back this way, you can deposit your shape to go right here. And then darken your shape as well. So this would be as if you went 270 degrees this way. Okay, so if you need help with the protractor, you may Google it, you can come in. I'm just trying to show it to you. Well, I can't even actually post a protractor on the screen. So again, I'm trying to do my best, if you're not in class today. Okay, the next thing we're going to do is we're going to say, can you identify, what kind, if it's a rotation or not? Okay. Again, with rotations, as all these things, rigid transformations, the preimage and the image will be congruent. And so it appears, excuse me, that this is a center of rotation, and you wrote, I don't know which one's the preimage or image, they don't tell us. So you're going to have to say, well, let's draw a segment, to one of the points and draw a segment to another point. We can measure that angle. If you can just eyeball it at this moment, but if you want to use a protractor, how many degrees is that rotation? Well, that's going to be 90 degrees. Okay. And so the next one is not a rotation. That's more of a reflection. Do you see that? And then this one also is a rotation. So the rotation center, it looks like it's about here. You could draw to like common points and be like, can I tell like back to here and like over here, like how many degrees of it? And you can measure that in your protractor to see how many degrees is that roughly. Okay. So you have to draw it to common points on each shape. And it looks like it's more than 90. Okay. And you could use your protractor to see, okay, is it more like 100? Is what's going on? And so, and you probably would need to extend these lines longer so you could use your protractor appropriately. So I would place my protractor lined up maybe with this one down here. And then I would measure to see, okay, how many degrees would this be? And it would probably be like about 100 degrees. And so you could do that. Again, if you don't have, let's see, a grid, these transformations, you can do a lot with a protractor. The next one I'm going to demonstrate in class. I'm not sure that I'm going to be able to do the best on this, just freehanding it and talking about it here, but let's do it just a little bit. Okay. And so this next picture says, hey, let's take this triangle on the right and let's rotate it the angle you see on the left, the A. Okay. And so if you would like to rotate this through space counterclockwise, that angle, okay, how you would do it if you just had tools and you didn't have tracing paper wouldn't be too bad. You just put it on a stick, you'd measure that angle, you would rotate at that angle, then you'd redeposit it with your tracing paper. But if you don't have tracing paper, we're trying to use a protractor and we're going to try to be this. Again, I'm not going to ask you to at all do this, but how you would do it, okay, is you would measure this length to here, okay? And what you would do is if you knew this degree right here, you would go left that angle, okay, using your protractor, and you would make a new point equidistant from this point. Okay, so I'm going to kind of eyeball and be like, okay, if I go this angle, and I do a same distance, this is my new bottom point in the triangle. Okay, and so I'm going to erase that. Okay, and so I could even label that and be like, okay, if this is point, A, then my new point for the bottom of this triangle is going to be over here. And if I want to do my next point, okay, I'm going to get another color if I can. Black. Okay. And so if I want to say, okay, let's draw this far point here. And then I'd have to measure it with a ruler and be like, okay, now I'm going to go, down or counterclockwise that angle. I'm going to deposit a point that's going to be the exact same length away from the center. And so again, I'm matching this angle here and I'm matching this distance from here to here. And that's going to be this new point up here. I'm not going to make you do this by yourself, so don't even worry. I could make you do the tracing paper, but I'm not going to make you do this right here. And then to get the last point on the top right, we're going to say, how about draw a segment to that point right there, okay? And then apply the angle, okay, this angle right here. And I have to also make it this length of the green stick. So let's go that angle over. Okay. Oops, my marker's not working. Great. And then we could probably need to make it a little bit bigger. So let's make it a little bit bigger. And you would use a protractor if you were actually trying this. And when I show it in class, I will, but I just don't have a protractor on my computer. And so and you want to do the angle, and you want to do the distance. Okay, that's what has to match. And if I did it right, then my new shape would be congruent to my old shape, but it's not. Okay. Problem is that it's a little bit too wide. Okay, and so I'm going to bring this in just to kind of fudge it. And so does it look like I rotated this about the same angle as this one right here? Yeah, it kind of does. And so how you do it is every point has to be rotated that amount, that number of degrees, okay, counterclockwise, and it has to be equidistant from that point of rotation. So it's kind of a cool operation, but it's not really easy to replicate on your own. Okay. Now here's what we're mostly going to be doing. We're going to be saying, here's a graph paper. Okay. Putting it on Rene Descartes' coordinate system and saying, okay, if I have a shape, can I rotate it with the center at the origin? So all these ones here are going to be when the center is at the origin. Okay. There are ways to do it with the center at specific points on the grid. And that's not something we'll be conquering because I think we're trying to get the basic principles here. Okay. And so if you take all your points and you graph them. So I'm going to start by graphing these original points, the pre-image points. 0 is 1, and that's W. 2 is 4. Okay, that's X. And then we connect them in order. 4, 3, 1, 2, 3, 4, 1, 2, 3. And then this is Y. And then Z is 2, 0. Okay, so we've got our original shape, our pre-image, and we're going to rotate this, and this with the center being here. Okay, so we could do it on patty paper and be like, oh, let's draw a segment to the stick. Let's, rotate it 90 degrees using the protractor and make it work. But that's really not necessarily super accurate. And so let's use a formula. Okay, to rotate it 90 degrees, what you do is you take every point. The formula says, I'm going to highlight over here. The formula says you do you first do the y coordinate, and you do the opposite of the y, and then you write the x. And so you switch the y and the x. You do the opposite of the y coordinate, and then you do the x coordinate as it was. Okay. Negative does not mean make it negative. It means do the opposite or times by -1. Okay. So be really careful that you follow those directions. And so the next point would be W prime. And so you put the y coordinate first and you do the opposite sign, what it was before, and you put the x coordinate unchanged. So x would be -4 and then 2. And then y would be prime, would be -3 and then 4. And then this would be z prime would be 0. Opposite of 0 is still 0. And then 2. And so we just plot these points. And so -1 is 0. So this is W prime. And you should label these points. -4, 1, 2, 3, 4, 2. Okay, that'd be x prime. And then -3. 3, 1, 2, 3, 4, and then 0, 2. All right, and so this kind of feels wonky. This is Z prime. Okay, but the thing is that if you make a segment, draw a segment, okay, draw that stick like we talked about in the earlier part. We say, okay, I'm going to draw a stick that is going to be to a common point. And then, so if I draw a stick that goes to Z, and I draw a stick to a Z prime, okay, the angle form there is 90 degrees, isn't it? Counterclockwise. And so that's how you can say, hey, guess what? They're congruent. I drew a stick to the common point, okay, the pre-image and the image point, and that angle does match what they asked me to do. Okay, you don't have to draw that stick, but if you're kind of wondering, did I do it? Yeah, you did. If you put your thing on like a stick and you rotate it 90 degrees, that's exactly what it would look like. If it doesn't, you might have botched your formula, or you might have botched your plotting, because it's easy to plot points inappropriately. Okay. Now we're going to rotate a shape 180 degrees. The formula for 180 degrees is going to be, you just change the signs of both X and Y, okay? And so let's plot our original points, our pre-image. Our pre-image is going to be S is 1, -1. So that's S. And then 5, 1, 2, 3, 4, 5, -3. That's T. And then 3, 1, 2, 3, -5. Okay, so that's you. So you've got 3 points. You got a triangle. This is our pre-image. And we want to rotate it 180 degrees. So it likely is going to end up in the second quadrant, isn't it? You know, you can imagine going 180 degrees, you know, with the center of rotation being the origin here. Okay, so how to do this? Our rule is you do the opposite of x and then you do the opposite of the y. And so to do the opposite of x and y is going to be, it's kind of like when we reflected across the y equals x axis. Remember you interchange x and y? Actually, I don't know why I said that, but you just do the opposite sign of each x and y, and it kind of goes diagonal in the quadrant. So it's going to be -1 and then 1, and then this is going to be, that's s prime, and then t prime will be -5 and then +3. Each one turns opposite, and then u prime would be -3 and +5. So let's see how that goes. So if you go -1 and 1, that's s prime, and then you do -5 and 3. That's t prime, and then -3, and then 5. That's u prime. So then you can draw your new shape. And if you draw a stick to the common point, notice this is 180 degrees, okay, to go through the axes, which is kind of cute. Now, if we want to go 270, we expect that it looks like quite a move, doesn't it? Okay, from their pre-image. So let's try this. If you plot A to be -5 and then 3, it's kind of infringing on its space, but oh well. -2 and then 3, that's B, and then -1, -3, that's C, and then D is -4 and then -3. Okay, so we've got a quadrilateral. Looks like it's probably a parallelogram. So you've got that, and you should use a ruler because this looks terrible. But again, I don't have a ruler on my computer, and it's very hard to put a ruler against the computer because it's a touch screen. And so use a ruler when you're doing these. And then if we want to rotate it 270 degrees, the rule for that is to go y and then do the opposite of x. Okay. And so for A prime, we're going to go the y coordinate, and then we're going to do the opposite of the x. And then again, remember, negative means do the opposite or times by -1. So we're going to do 3, the y coordinate. We're going to do the opposite of x. C, we're going to do prime. We're going to do the y coordinate and then the opposite of x. And D would be, prime would be -3 and then the opposite of x. Okay, so I'm going to grab another color. And we're going to graph these points. So 3, 5. Okay, pen's not working. Okay, here she is. A prime. And then 3, 2. 1, 2, 3, 1, 2. It's going to be B prime. And then -3, 1. 1, 2, 3, 1. That's C prime. And then -3, 4 is going to be D prime. Use a ruler and connect these. If you want to check it, how you do it, remember to check, you say, you draw a segment to common points, pre-image and image points, and check their angles. Okay, so I'm going to go to C. So if you go to C and C prime, okay, if you go counterclockwise, okay, you're going to end up having gone 270 degrees. Okay, so I feel like what we've talked about today has been how can you rotate around a center of rotation a certain number of degrees. If you use patty paper, you just have to know, trace it on the patty paper, deposit it on the back, and then measure the angle you want it to go, and then redeposit it in the new location. You do need to have it kind of on a stick. You need to draw a segment from a close point to the center, and then that way when you rotate it, it retains its distance from the common distance from the center. Okay, if you want to use just a protractor and a ruler just to kind of measure an angle, you have to do every vertex of every vertice from the center point, the center of rotation. You have to measure both the angle it has to go as well as its distance, and you deposit that new point in its new location, connect them. Okay, and if you did a good job, you've got it. The one I'm going to ask you mostly to do would be, can you take a coordinate plane and take a figure and then rotate it either 90, 180, or 270 counterclockwise using the formula for what you do to the points. All right, thank you. Have a good day.